Continuing with our bisectors, now we're going to look at perpendicular bisectors. Again, word bisector means roughly cuts into two congruent parts. So the perpendicular bisector cuts each of the sides of the triangle into two congruent parts labeled. And notice that I'm using different number of tick marks to make sure that we don't get that confused. Where the perpendicular bisectors intersect or are congruent, you will find the circumcenter. All right, so if we move down here, point D is the circumcenter, which means it has cut each of these sides into congruent segments. So if we look at the side containing segment BE, it would be congruent to the segment EA. And remember, you can exchange the letters of a line segment. AF would be congruent to FC. And CG would be congruent to segment GB. Again, this is because we are using the perpendicular bisector, and by definition, the bisector cuts each of the sides into two congruent parts. Now, the circumcenter, the distance from the circumcenter to the vertices of the triangle is congruent. So that means the distance from D to A, D to B, and D to C would be the same. And since the measures are equal, that means line segment AD is congruent to line segment BD and is congruent to line segment CD. Okay. Now, not only do you have the distance from the circumcenter to the vertices being congruent, you also have formed congruent triangles. So if we look at the following triangle, AED, there's triangle AED. These two sides are the same length. AD and BD are the same length. So triangle AED is congruent to triangle BED. Would be that triangle. Those two are congruent. If we look at triangle BGD, notice that BG is the same length as GC, and BD is the same length as CD. So we have a congruent triangle. BGD is congruent to triangle CGD. So those two triangles are congruent. And last, we have triangle AFD. And if we look at our two triangles here, AF is congruent to FC, AD is congruent to CD. So we have triangle AFD is congruent to triangle CFD. So we have three sets of congruent triangles created within our original triangle because of the perpendicular bisectors locating the circumcenter. Another piece of information for the circumcenter, kind of similar to the incenter. If you put the point of your compass at the circumcenter, you can draw a circle where the vertices of the triangle will be touching the circle. And again, continuing with the diagram here, your circumcenters can be on the interior. That's if it's an acute triangle. It can be on the exterior if it's an obtuse triangle. And it will actually be on the triangle itself if it is a right triangle.